Okay, next page of notes, take your blank pages, page 9, fold it in half, and then fold it in half again. I'm just making 4 nice pretty sections here. And we're going to start on the far section here, and we're going to talk about each of the variables here. So I'm going to start with the far section, and I'm going to talk about, let's talk about pressure here. So pressure, P. And our common pressure that we use is atmospheres. I personally like atmosphere the best because, you know, it's one standard atmosphere. So 1 atmosphere is equal to 760 millimeters of mercury, or 760 torr. There are a buttload of units of measurement for pressure, and which one you use is determined by what they've given you in the problem or how much you want to change. And pressure is caused by, again, I'm being a little redundant here, but that's okay, molecules hitting the walls of the container. That's what causes pressure. It's not them hitting each other, because remember, that's not the significant part. It's them hitting the walls of the container. And it's measured with a lovely tool called a barometer. So draw this. You have, let's say, a pan. It's a big pan. And within this you have mercury. This is how the first one was made. So here's mercury. Mercury's silver, so I'm going to grab it. There's my mercury.
Wait, is this all in one section?
Yep. Got a pan. It's filled with mercury. This is how they started doing this pressure. And this stuff is mercury. And you have air. Obviously, it's just an open pan. You have air pressing down on it, right? And what they did is they had a glass tube that had marks on it. It was a graduated marking tube. And so air is pressing down on here this way. And they figured out how high up the air pressed the mercury into the tube. So if it pressed it up 760 millimeters, that would be, what, 76 centimeters? 76 centimeters, that's almost a yard, right? Almost a meter. So they had these really long glass tubes, right? Really tall ones. So 760 millimeters would be 76 centimeters, right? Which is almost a full meter. Again, close to a yard, if that's what you're familiar with. So when we talk about the atmospheric pressure being 760 millimeters, they're saying, hey, the air's pressing down so much on here, pressure pressing down so much on here, that it pushes the mercury up to the tube up to 760 mils, or 76 centimeters up there. That's where they're getting their numbers from. 760 millimeters of mercury. The torr thing is, somebody said, hey, let's name this after Torricelli in honor of him. Let's name it after him for that. So 760 torr, 760 millimeters of mercury, same thing here. So that's where they came up with this. And mercury, they used mercury because it was heavy enough, because if they used alcohol, then they'd have to have something that's a lot taller than a meter. They'd have to have this huge, tall glass tube. So they used a substance that was really heavy, so it takes a lot of air pressure to push it up the tube. So that's why they use liquid mercury. And it doesn't expand or contract much when it gets hot or cold, so that's another reason they use mercury. So air pressing down on the mercury, again, pressing, pressure, so the air pressing down on the pan of mercury causes the mercury in the tube to rise. And at sea level, at 0 degrees Celsius, it will rise up 760 millimeters. That's standard pressure. So 0 degrees Celsius, it's going to push it up 760 mils up that tube. That's about this much. So you've got a pan of mercury that just from air pressure, it's going to go up that tube 760 milliliters. That's amazing. Once you've written that down, go ahead and stop there.